matter. Can you all hear me?
Yes, sir.
Yes, sir.
We can hear.
Yeah. Okay. Right. So, can you all see the screen? Yes, I have a bit of internet problem today. I don't know what is the reason. Right. Hope you can see the screen. Have you all?
Yes, sir. We can see.
Right. Now we will quickly execute the program and see. So this is the output that you will get as the right. So this is yesterday I have interpret the results. Right. Few things that we'll have to look at. First thing is you test for beta 1 is equal 0 and beta 1 not equal 0. That is my null and the alternative. That is the testing. Then we have looking at this, we can predict, give the predicted model that is 0.58075 plus 0.08347 x. So this is my predicted equation. By looking at this value, I can give the predicted equation. Okay, I have explained all these yesterday. Talis Kumar, do you need the explanation again?
No, sir. No, sir. It's okay.
Right. Okay, right. The second command is based on the correlation. We can get the here we can get one information, that is our R square. That is, yes, R square. R square. Whether you write R square in this way or in this way, both are correct. Usually we write it with capital R square. Both are correct. Huh? There's no difference between simple R square and capital R square. Both are explaining the same thing, but usually this is the correct way to write the R square. Okay, capital R square, which is the coefficient of determinant. So this is equal 0.95 in our case. It is the closest two decimal point, 0.95. Or in other term, if it is a percentage, it is 95%. So out of total variability, 95% of the variability can be explained by the X variable. Here the X variable is, what is the X variable? We said the diameter. Y variable is the yield of rubber. Yesterday we have seen, yes. Right. So that is how we can explain that. Now we can go for correlation. We want to get the correlation. For that, we'll have to give another different command. It is called as proc correlation. Variable. Two variables. We have here only two variables, so that it goes as variable x and y, or y and x, it doesn't matter. So this is the command for getting the correlation. Suppose if I have so many variables, let's say if I have in the input, I have variable, let's say input height of the plant. So normally growth parameters tell me the growth parameters of plants, height, right? What else? Dry weight, fresh weight, right? What are the other growth parameters? Anyone? Height, dry weight, fresh weight. So likewise, you can enter the data, any data. So here we will enter the data, height data, weight data, or dry weight data, fresh weight data. Let's say moisture content, MC, I will put it as moisture, leaf moisture content, or leaf area, right? I will say leaf area, for example. So these are physiological parameters of tree, growth parameters. I will say leaf area, LA, leaf area, right? Leaf area. Then you can measure any parameters. Then after that, you can enter any number of data. Now I want to see how these variables are correlated. So what we will have to say, correlation, variable, we can include all these variable, height, dry weight, fresh weight, leaf area, etc., etc. Then you can run the program. So it will give a huge matrix, like height in both cases. You know what is matrix. Then dry weight in both columns and rows, fresh weight in both columns and rows, leaf area in both columns and rows, and so on. So if you look at the correlation, this is 1, 1. The correlation is exactly 1. All the diagonal you could see is come as 1. This is called as main diagonal. In mathematics, you have learned this. I hope in mathematics, you could have heard the term main diagonal. Let's say it's like 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a matrix. In this matrix, the main diagonals mean these are the values called as main diagonal. So that means 1, 1, 2, 2, 3, 3. What is the position of this? 1, 1. What is the position of this? 2, 2. What is the position of that? 3, 3. So this is called as main diagonal coding. Can you remember why 1, 1 means first row, first column? Why 2, 2 means second row, second column? Why 3, 3 mean third row, third column? We talked about it, right? In other cases as well. So likewise, this is called as main diagonal. So main diagonals are with the value 1.0 always. The other off diagonal, these are called as off diagonal. Off diagonal, these are just mathematical term, off diagonal. Off diagonals are with the same values. If I get here, for example, 0.8 something, so here also I get 0.8. If I get, in this case, the value 0.9, here also I will get 0.9. Right? So likewise, the results comes as such. So we can run this and see. So you see, this is the diagonal which I was, sorry, this is the matrix which I was referring. So you see y, x, here also y, x. So it goes as a matrix. This is called as correlation matrix. So you can see here the main diagonal. This is what I said, main diagonal. These values are always 1. Definitely it is 1. These are off diagonal. Off diagonal here, whatever the value here, it is same. So y21 value will be same as y12. These values will be same. Because you see, this is y12. This is y21. So it's a same thing. So that for the explanation, we can explain only one part. We don't need to explain all, because here it says, in one case it says can you all hear me? Normally this is not happening every day, but today I think something wrong. Can you all hear me? Can you all hear me?
Yes, sir.
Right. Okay. Right. Okay. So this is the diagonal. So here it says the relationship between x, y, and x. Here the relationship between x and y. So these are actually same. So we can say either this.
We
can
can
explain
hear.
this. Yeah. We can explain either of this. Both are having same value. You see. Considered as peak hours, Manita. So this is considered as a bit of peak hours. So that is the problem. All right. So sometimes it is not stable. You could see, right? The screen. Tanish Kumar?
No, sir, we could not see.
Oh, you could not see. Now? Can you see Tanish Kumar now? The
We
screen.
could not hear anything, sir.
Can you all hear me?
Sir, we could not
Yeah.
hear anything.
Maybe now it's okay, right?
Yes, sir, now we can hear.
All right. Maybe problem with the connection today. It's giving more problem, but yeah, we will see. Right. So here the correlation value, correlation coefficient, which I have explained yesterday, the value is 0.97. The closest value will, I mean, 2 decimal value will be 0.98. I can write it like that. So it is giving the strength of the relationship. Right. So this is significant. You see here, this is the p-value. so that we could say it is significant. It has a very high strength correlation. Strength of the relationship is very high, so that we could consider that. Right. Okay.
Okay, sir.
Any questions? Anybody would like to ask any questions? Right. Today, before I go to the SAS, we are going to discuss about coding system. Right. Coding system is important in SAS actually. So I will share the information. Hello? Yeah? Anybody want to say anything? Can you hear me?
Yes, sir.
Okay. So coding system. Let's say this is my model, Yij. I'm going to learn about CRD. Right? Yij, this is my model plus alpha I plus the error term. You keep your nodes close by. So here I is from 1 to T, right? J is from 1 to R. How do you call this T? It is the
Number of treatments.
number of treatment. T is number of treatment. What is R?
Number of replicates.
Number of replicate. R is number of replicate. So in CRD, number of replicates for each treatment not necessary to have equal replicates. But if you have equal replicates, the precision is equal, right? But not necessary. Right, let's look at your coding. If I say Y11, how we can say this Y11, how we can express?
First replicate of first sample.
First replicate of?
First sample. The first
No.
treatment. First treatment.
Treatment one.
Yeah, observed value of first treatment in first replicate. What is Y31, 32? This coding is important. That is why I'm talking about. Anyone?
Observe value of third treatment in second replication.
Okay, third treatment in second replicate. Right. Now this coding is important for us. For example, here I have replicate. First, second, third. I have simple example, replicate 1, replicate 2, replicate 3. I have 3 treatment, T1, T2, T3. So I will give some numbers, don't worry about it. 20. Right? Right. Now I'm going to code. Let's say I'm going to say treatment, replicate. let's say treatment and replicate, right? So I will erase it. For example, treatment, replicate. These values are, let's say, yield. Now, I'm going to look at the coding. I'm going to put the yield up first. What is the coding there? Which treatment, which replicate?
Y11.
First treatment, first replicate. Right? What about this?
First treatment, second replicate.
So likewise, we can code all these values in relation to treatment and replicate. Can you code all these first as a practice? Complete this table, but this table has to be coded in a sequence. I started with 1, 1, then 1, 2, 1, 3. You shouldn't do like this, 1, 1, 20, then 1, 3 is 29, then 1, 2 is 24. Do you see there's a sequence here? Do you follow a sequence?
No, sir.
No. If you don't follow a sequence, SAS will not accept. But you see here there's a sequence. 1, 1, 1, 2, 1, 3. Next one is 2, 1, 2, 2, 2, 3. Next one is 3, 1, 3, 2, and 3, 3. You can complete all of them. You can complete all of them. So now we are going to enter the data in this form in SAS. That is very important. We are going to enter the data in this form. This is called as coding system. So the SAS will give results in the treatment as 1, 2, 3. So we should know what is treatment 1. We assign a name. Maybe this is nitrogen fertilizer. Our treatments are nitrogen fertilizer, right? So this is 10% nitrogen. This is 20% nitrogen. This is 30% nitrogen. So I have coded this as 1, 2, 3, right? So 1 mean it is indicating 10% nitrogen. 2 mean it is indicating 20% nitrogen. And 3 mean it is indicating 30% nitrogen. Clear? All right. So everybody should understand this coding. Are we in or did I miss? Connection is there?
Yes, sir. Yes, sir.
Right. Yes, anybody doesn't understand the coding? Coding is important in SAS. Otherwise, you will be in trouble. So everybody should know how to do the coding. Right. Now we will go to the program. Okay. Before program, I'm going to take the same example that you have done as a homework. All right. I'm going to take, can you all see the slide? This is, yes, this is from one of your colleagues. You have done this as a homework, right? Tanish Kumar? Homework, I said.
Oh,
Right,
sir.
right. This class la sedaningla, what la sedaningla?
The assignment or something.
Assignment, right. Assignment submit பண்ணியாச்சோ இன்னும் பண்ண இல்லையோ?
Submit பண்ணியாச்சு.
பண்ணியாச்சு போய் சொல்லக்கூடாது. அப்புறம் நான் இப்ப இதுல ரிசல்ட்ஸ் எடுத்து காட்டினா எனக்கு தான் பிரச்சனை. சத்தத்தை காண இல்லை.
இல்ல
No, sir.
sir.
This one we did in the class.
Class. Right. Okay. This one did in the class. Right. Okay. So no assignment, right? Right. Now tell me how, let's say my coding. Here I am taking I as treatment, J as replicate. I as treatment, J as replicate. Right? So suppose, let's say here in this case, I am going to erase this, right? So I will write it as I as treatment, J as replicate. Now tell me how I can write this first one. Here we are going to, this you have done in the class. So variety, I'm going to evaluate the varieties. How I can write this? Which I want to investigate. I want to investigate if there is a difference between the variety. So if that is the condition, tell me how I can enter this value.
Treatment.
No. In coding. Why? Coding. I'm asking the coding system.
1, 1.
Yes, this is 1, 1. What about this?
1, 2.
1, 2. So this is 1, 3, and so on. 1, 4, 1, 5. Tell me, what about this? How do we code it?
2, 1.
2, 1. This is 2, 2. How about this one? The last one.
Why 5, 5?
5,
5.
5. Okay. Right. Now, 5, 5. Yes. Coding is 5, 5. Here we have, this is indicating treatment. The second digit indicating the replicate. Right? Okay. Tanish Kumar?
Sir.
Right. Finish writing? Right. Who is having a SAS screen share? Who is having a SAS screen share? You'll have to enter the data also. The same data you'll have to enter. Can somebody share the screen? I have given the command to share. Can you share it? Somebody? Who is going to share?
Sir, my area train, sir, so I can't
Training.
share.
Then who else can share? Peony?
Yes, sir.
Can you share?
Okay.
I hope everybody has your own notes also along with it. Right? Right, good. Now, can you enter the data? Can you enter the information type data from first line data? Palani line එක type කරන්න. Then කරගෙන යන්න ඕන data මොනාරි නමක් දෙන්න pioneer whatever it is. Whatever you can give the name because it doesn't matter. Okay. All right. Input. Can you remember in earlier case, how did I enter the data? Not in SAS, but before showing you a PDF file, I showed entering the data. What are the information that we want to enter? Yes? What is the data that you will have to enter in this example? Anyone? Treatment, enter. Treatment, replicate, and yield. Enter correct? Yes, enter. Short name is enough. Yes, treatment, rep, REP, and yield, YLD. Oh, yes, okay, whatever it is. Semicolon. Cards. Then you'll have to enter the first treatment, right? First one. Enter current. First treatment, space, first replicate, space. Oh, where are prashne, internet. You also have problem internet. Yeah, everyone has problem internet. Problem. Close current. Yeah. Who else can do it? Pionita prashna again, Yeah, connection problem. Yes. Peony, you better, thanks. You better go out from the screen sharing. I will enter the data.
Shall I stop share?
Yeah, you stop sharing. Yes. Because there's some internet problem. Screen share stop current. Yes, thanks. Right. Somebody, I will enter the data. Somebody can read the values. Tanush Kumar.
Om sir, nan vasik.
Oh, yeah. What I say is just a second. In the poruk vasikanum. So
1 1 1 2
1 2. You'll have to read like this. Huh?
Okay, sir.
So I will enter the data because otherwise it takes time. So I will type, right? Give me a second. Data, because it is CRD, so I give the name as CRD. Input, treatment, then replicate, then yield, YLD. I just put yield as YLD. Then cards. So everybody, I think you can read this. Right. 1 1.
1 1 1.6.
You can give only the value, huh?
Okay, sir. 1.9. 1.5. 2.1. 1.7.
You can see whether I'm entering in a correct order.
Okay, sir. Next one, 2 1, sir. 2 1.
Oh, sorry.
1.9. 2.4. 2.3. 2.2. 2.4. 2.2. 2.1. 3.1 next.
Yeah, you tell me the numbers, then I will type it later. You tell the numbers. Order value.
And the value மட்டும் சொல்றோம் சார் இல்ல.
Yes.
Okay sir. மூன்றாவது சொல்லண்டா 2.3 2.6
Wicket சொல்லுங்க.
2.4 2.5 2.7 1.2 0.8 1.0 0.9 0.8 2.6 2.8 3 2.9 2.8. That's all.
Okay, right. Thanks. So I will insert the other coding. Others also can now type it. You can type this in Excel and bring it here. I don't, now I am not going to show you. I will show you a little later, right? Not today, maybe if time permits, I will explain today how we can bring the data from the Excel sheet. If you bring it directly, the old version of SAS, you can bring directly, but in the new version, you cannot bring directly. There's a bit of problem. So I will show you how to convert this and bring it from Excel, because entering this kind of data in Excel is very easy. Right? Thanesh Kumar, have a look whether it is correct, whether our entering is correct.
Correct.
We have entered all the data. Is that correct?
Yes, sir.
This coding is important. This coding is important. So everybody knows what is 1, 2, what is 3, 3,
Sir,
what
in
is 4,
1.4.
2. Yeah,
In 1.4.
yeah, maybe I might have done.
2.1.
In 1.4, this is
2.1. 1.4.
1.4. Okay. 1.4. This one?
2.1.
Yeah, cross-check all the values, because check all the values, everyone. It is the same example that you have done, right? Right. So we have the upper part and the lower part. Now we want to, I have already talked about this model. What is the model, CRD model? Yij is equal mu plus alpha I plus the error term. Can you remember yesterday when I discussed with regression, I said that in the model, few things has to be incorporated. In the model, y equal, right? In this case, y is equal. We'll come to our example. This is why, according to this, what are the things that we'll have to include in the model? So this is a CRD model. Computer will calculate this grand mean and the error. If computer calculates the grand mean and the error, what will have to include in the model? Anyone? Only this effect. What effect is that? Treatment effect. So I enter this as a model. Only y is equal treatment. Right. So under the classified, Under the model, I'll have to enter this. I will come to that. Then, can you remember, I introduced, there's a term called as class. What is meant by the class?
Based on what that is classified.
Yeah, classified variables. So here, how many variables are there total that we have entered under the input?
3.
3 variables. We have entered 3 variables. So out of 3 variables, how many variables are classified? By looking at the data, how many variables that we have classified? Or in other term, categorical data. How many categories are there?